It's Dell still here? Dell, yes. So I'm actually, you guys will be very proud because this is the last session, and I would make it interesting, but I also want to let you know that actually I delay my trip to China so that I can be here and do this with Professor Sujay King Liu. So that means what? That means, she is someone that I respect greatly, but she's also an outstanding leader at UC Berkeley. She is the highest ranking Asian American leader at UC Berkeley currently. And she was also the first woman chair of UC Berkeley's #1 major, EECS, Electrical Engineering and Computer Science, which, by the way, we just have a Turing winner. For those who don't know what Turing Award means, that is the Nobel Prize in Computer Science. So anyways, so that's the reason why Berkeley is ranked first in this area, because we are tremendous in terms of technology innovations. That being said, as has been already kind of explained, we're very honored to have Professor Sujay King Liu here today. As I said, she's a distinguished professor, and by the way, I have never in my lifetime known an individual with that many patents. 95 patents. She just kind of updated. I thought it was 90. It's 95 patents, right? For a woman, right? Clappings, right? Now, another 70 pending. So when it's all done and said, it's going to be 170 patents. Wow, yes, I can see a lot of enthusiasm, including some friends here from Berkeley. Hey, who's from Berkeley, by the way? Whoa! Anybody from Stanford?
It's okay, I'm from Stanford.
I only see one. My friend Tianming over there. Right? And hey, Tianming, you're outnumbered, by the way. But Tianming actually knows Berkeley is for the better because Tianming's daughter is studying at Berkeley. That I know. See? All right. So anyways, I'll keep it interesting as said and short and sweet as well. But anyways, and actually Professor King Liu just actually also, is the inventor of what we call FinFET. Now, let me ask the question. How many of you guys know Moore's Law? Raise your hand. Are you sure? I think seems like to be, okay, it's about a third of the people who know Moore's Law. But how many of you uses computers? Come on. If I don't see your hands up, you don't belong here, okay? All right, I see everybody's hand now. So the reason why you're able to use your computer and it gets cheaper and cheaper, it's because of Moore's Law, right? And it's significant. And the fact is, Moore's Law is able to continue is because of Professor King Liu's invention. What do you call FinFET? FINFET, right? And actually, as a matter of fact, because of that invention, she has won many, many awards, one of which I actually just like a few weeks ago, I was in Washington, D.C. She actually was inducted to the National Inventors Hall of Fame. Who are the guys who won this award? Well, it includes Alfred Nobel. Who's Alfred Nobel? The Nobel Prize is named after Alfred Nobel. And also Gordon Moore himself, right? So, I think with that said, let's refresh, us again. What is the importance of Moore's Law and why this is relevant? Because we're actually talking about AI. Why is very relevant for the era of AI? Professor King Liu, please.
Okay. First of all, thank you very much for inviting me. It's a pleasure for me to be here. It's wonderful to see so many people still here at the end of the long day. I think you had a very exciting program all day. But Chuck is really great at waking people up, instilling energy into any discussion. So Moore's Law, it really is about increasing the performance of the computing chips. Every 2 years, we basically double the number of computing operations we can perform per second, and for about the same cost of a computer chip. So how is this possible? Well, it has occurred over the last 50 years with very steady improvement in the manufacturing process for these computer chips. If we can improve slightly every year to fit more transistors. A transistor is an electronic switch. So more transistors on a chip, the chip can do more, and the cost of the chip is staying relatively constant. So because of Moore's law going on for the past 50 years, slowly and slowly the computers have become more capable. They do much more than computing today. Your mobile phones do much more than computing and serving as a telephone. And so information technology has become more affordable and more pervasive. So really the proliferation of information technology and communication technology really has been enabled by a few decades of Moore's law, just the industry steadily making progress. And the way this works is that as you make better products, more people buy the products, new products every year. And so the companies can make money, and if they profit, then they invest to advance the technology further. So this is a virtuous cycle that has gone on for the past 50 years. So each year is a small step-by-step improvement, but I think in the end, the industry has grown exponentially as the computing capability has also grown.
Very good.
Well, so that's really enabled artificial intelligence to be like happening in real time, right? Machine learning.
Yes.
It's just the faster you can do computations and more affordably, then many more applications such as AI are really enabled by this technology advancement.
Yeah, and actually it's really interesting, as Professor had mentioned, it's like, the last 50 years. But you actually have a really interesting graph. By the way, that's the reason why actually I want you guys to check it out too. It's like, I'm not showing here, but because I want you guys to go and check it out, because if you look up Professor King Liu's bio, you're probably gonna be able to find a graph that shows 120 years of Moore's law, which I thought is very interesting. Can you kind of please tell us a little bit more about this?
Okay, so this graph is available on the internet. It's called 120 Years of Moore's Law. So Moore actually published his paper sort of showing how the industry was doubling the performance of computing chips every 2 years. He published that paper first in 1965, which is less than 120 years ago. But basically what happens is if you look at the number of computing operations per second for the constant dollar, you can actually go backwards and see, starting from 1900, the year 1900, when computing was done with mechanical devices, it's made 18 orders of magnitude improvement in number of computations per second for constant dollar, starting in 1900. So from 1900 to 2020, basically 18 orders of magnitude improvement in the number of computations for the same cost. And so Moore's law actually is an extrapolation of what the industry had already been doing for, I guess, more than 50 years before transistors were invented. So it's just very interesting and so what's exciting about that is with continued innovation, so we were talking about innovation earlier today, we can continue that trajectory, right? We can expect another, orders of magnitude improvement in computing capability. You can imagine what will that enable in the future. We need a lot of innovation to come up with applications for such computing capability.
Very interesting. And actually, on this topic, Professor King Liu is an expert in semiconductor, which of course we just discussed. ZTE, by the way. Actually, funny enough, tomorrow I'm gonna meet my friend, which is the former CEO of a ZTE, by the way. But I'm going to ask him personally how he feels about what's going on. But it's what I guess being an expert in semiconductor, and given semiconductor is a really, really hot topic in China now, and of course U.S. and China. What do you see the future of semiconductor? Why FinFET has such impact in our industry in the future?
Okay, so how many of you are electrical engineering? Probably, oh wow, a few, that's great. Okay,
good amount of you.
A FinFET is a type of transistor. So a computing chip today, the most advanced computing chips have tens of billions of transistors. And a digital computing chip, really all the transistor needs to do is turn on and off, conduct current or not conduct current. And it turns out that as you make transistors smaller and smaller, it becomes more difficult to turn them off properly. When you turn it off, they still leak. So the FinFET is a transistor design that turns off better than at very small dimensions, like 10 nanometers. So bottom line in a product, the impact is that you can have better, more more energy efficient chips. So for the mobile phone today, when I ask students, what is the most important thing, or what would you like to see improved in your mobile phones? Most of the time it's more like longer battery life, right? So FinFET technology really allowed improvements in computing performance, but also lower power consumption. So you have longer life, batteries. So, but your batteries can last longer for the computing power. So that really is the main benefit of FinFET technology, allowing the performance to be high performance to be achieved, but with lower energy consumed.
Hey guys, that means all of you. That means like everyone who's using a phone today. Come on, you got to do a round of applause for this invention, right? That Professor King has invented for us that benefited everybody, right? Thank you.
It was a team of people at Berkeley.
Well, team of people, but you're one of 2 or 3 people, right? So a team of folks. Anyways, so I have changing topic a little bit, a few more questions. Changing topic a bit here and coming back to the place, as I said, Berkeley, where you started all these wonderful research. As a graduate, but you're really also a graduate of Stanford. And I was jokingly about Stanford, but Stanford, even though I want to kill Stanford on a big game day, but the rest of the time, I'm in good terms with Stanford. But how you really started your academia career, actually. You really started your academic career at Berkeley and really understand both the universities very well. And by the way, actually, out of the top 10 universities, Berkeley, however, is the only public university. Everybody else is private, okay? Just to kind of make a reference on that. So that being said, as a leader there for the last 20-some years, and Berkeley, right, as I said, just came out with a new Turing winner, Professor David Patterson, which is very well known for computer architecture. Right? So there's a lot of very talented, a lot of innovations coming up. So my question to you is, why is Berkeley so innovative?
Okay. Well, we have outstanding professors, and the professors help to attract the best students. I think many of you indicated you came. You got at least some of your education at Berkeley. I think really it makes a huge difference to have the best students come to Berkeley to work with us. It really is a virtuous cycle in itself. So we also have a culture. It's really ingrained in our tradition to collaborate. So we like to work together. The professors get along with each other, not only in one department, but in many departments. So we like to collaborate, and we treat our students as junior colleagues. I think really just the teamwork, and I think that's really what makes it a big difference. Also, the fact that we're a public institution. One of the main it's very obvious in our mission. The mission of our university is really to serve society, to help to make the world a better place. And that actually helps to inspire people in a way that maybe at a private university you can't really have the same inspiration. And also that one thing that sets a public university apart is access. We train many more students than a private university. And also, most of our students are on some sort of financial aid. Many students are first-generation college-going students. They come from the lowest economic, the income bracket. But when they graduate, they move on and reach the top 1% of the income bracket in our country. So we call this social mobility. People come from disadvantaged backgrounds, they get a good education at affordable cost, and they go on to succeed and become leaders in society. So that's kind of one of the mission, that's part of our natural mission of a public university. And I think that really inspires outstanding faculty to stay at Berkeley, even though we get paid less than professors at Stanford. But we think that we have maybe a nobler mission, right, to serve the world.
There you go. Hey. If I can summarize what Professor King said is, there's a phrase at Berkeley, it's called confidence without arrogance.
Without attitude.
And without attitude, right? Confidence without attitude. We don't say that we deserve it. We work hard at it, and then we make it happen, right? And we're cool too. We're very cool people, All right. So last two questions, because I have seen this signal. I guess please tell us what's Berkeley doing in U.S.-China cross-border partnerships.
Yeah, so, today, because of information and communication technology, we live in a globally connected world, right? So in order to train our students to be leaders in a global society, in a global economy, internationalization is really part of the learning experience. We need to expose our students to different cultures, right? They have to develop intercultural competency before they graduate in order to be able to function effectively as leaders in a future society. So part of this internationalization strategy is for us to partner with leading institutions in other parts of the world, including in China. So we have major collaborations right now with Tsinghua University and I guess Peking University and so on, really to develop close research collaborations because there are a lot of opportunities, to be frank, in China. The discussion previously, the government would really like to see innovation happen in China. So there's opportunities to attract Berkeley professors and students to spend some time in China, access resources there, and we have a mutually beneficial relationship. We share with our partners in China the keys to our success in innovating and also translating the innovations into the marketplace. So the entrepreneurial ecosystem, what we've built here in Silicon Valley and beyond, right, San Francisco, many places in China especially are trying to replicate that, and we are partnering with strategically with universities in China to help them. But I think in the big picture, I think if we're educating future leaders of China and the US, hopefully that will help to guarantee peaceful relationships between our countries in the future. So I think this kind of partnership really is important, not only for continuing to advance technology, but also to ensure that our world is a peaceful place in the future. Yeah. So for political reasons as well.
Well said. Actually, talking about Shenzhen, let me ask the question. This is sort of a test for you guys to see if you were paying attention. No, just kidding, actually. How many of you guys know, other than Huawei, okay, in Shenzhen, that's the quote-unquote largest unicorn company. Who is the largest, what's the largest unicorn company in Shenzhen right now? No, Tencent's not unicorn because it's publicly traded. So I say Huawei because Huawei is not publicly traded. Dajiang, DJI, well said. DJI is going to be a $20 billion company. And tomorrow, I'm going to meet the founder and chairman of DJI, Dr. Li Zhexiang. And Li Zhexiang is also a Berkeley distinguished alum as well. But that being said, actually, I'm gonna post a picture, okay? If you guys all kind of friend me, then now you see me picture with Dr. Li. But part of that is because the reason why is this: Berkeley's leading in AI, and I'm actually organizing I guess the largest AI conference in Hong Kong and Shenzhen in November this year. And Professor David Patterson has said, Chuck, I'm cool. I'm gonna come with you. We're gonna go to China. But for me to go to China, my wife, this is something you never heard it before from David Patterson, okay? This is a Turing winner, okay? This is even more precious than a Nobel Prize winner. The reason why is this: Turing winner, there's only 66 people who got Turing awards. Nobel Prize, everywhere, come on, everywhere, right? So, Professor Patterson said, okay, Chuck, I'm gonna go to China, but you need to take my wife to Disneyland. I said, that's not a problem, because we're gonna time it with the Shenzhen World Internet Conference, which is the most well-known conference in China, because Tim Cook, Apple's CEO, just spoke there this year, or this past year, and President Xi, of course, spoken there. So we're gonna kill two birds with one stone. I said, Professor Patterson, here's what we're gonna do. We're gonna go to Disneyland, but you're gonna speak at Shenzhen World Internet Conference, right? Because that's the most well-known conference in China. And then you're gonna speak at the AI conference with me. So that's what we're working on, by the way. And DJI, it's gonna be one of the key partners in this area because, of course, we're driving this Berkeley, Tsinghua, as well as Hong Kong University, as well as actually China's leading AIIA, which is Artificial Intelligence Industry Alliance. Now, this is a really interesting group. I mean, interesting industry alliance, I gotta tell you that, because I've never seen 4 most powerful ministries all come together and say, let's work with this AIIA thing. Well, 4 powerful industries are what? NDRC, what control all the money. CAC, the China Cybersecurity Administration, which, of course, Google and Facebook, everybody listens to. Third is the Ministry of Information Industry, which sets China's all the standard, 5G standard, by the way, and the Ministry of Science and Technology of China. Now, I happen to be friends with the person who's head of AIA. I say, hey, let's do this. Berkeley guys, we're very cool. You know, we work with you. We're cool. We're open source. This is exactly the point that Professor Xu King said. We're open source, and really, China loves that. So that's the reason why we'll get a timeout. But my last question.
No time.
No, always one last question. Good for one last question. It's about all of you because you guys stay here, right? Hey, give yourself a round of applause. Come on. You gotta give yourself. You guys stay all the way. So I gotta ask on your behalf a question that would benefit you guys here when you leave today, okay? And here's my question. The question is, how can all of them work with Berkeley? I mean, meaning industry, from an industry perspective, which I have a good fortune of working with you, by the leading China's high-speed whale, a buddy of mine is the chairman of that. It's a publicly traded company, multi-billion-dollar company. And I'm telling you, after meeting him, I took a trip from here to Denver, 36 hours, man. Took me but they're always on the way there, delayed by 3 hours, on the way back, delayed by 3 hours. Man, we're like third world country, man, trains. But anyways, put that behind us. I'm saying that from an industry perspective, how can industry work with Berkeley to make it a win-win partnership?
Okay, so Berkeley, we actually have a strong tradition of in welcoming companies to come and participate. David Patterson, actually, Professor Patterson has famously taught us, we invite companies to participate. What does that mean? You can come and interact with the students, the faculty, and if you like what you see, you can actually provide a little bit of funding to support a graduate student to work on a project that you really think is worthwhile. So we have many industry member research centers. The best way to learn about that is every February, the ECS department hosts a symposium that's open to the public, really, where we showcase research and we have an open house for all of these research centers. So keep an eye open for the Berkeley EECS Annual Research Symposium, BEARS. It's held every February on campus at Berkeley. Just keep an eye out for it, and you can come, you get free lunch and open house to visit all of the research centers that you're interested in. Yeah.
And if you've never been there, this year is Berkeley's 150-year anniversary, okay? So this is time to celebrate and hang out with the cool people. And I'm going to China. You can hang out with me in China, and then come back, we'll hang out again. Thank you so much, Professor.
Thank you, Chuck. All right, thank you. Thank you all.